one of the first discoveries on the subject of medical geology is here on the foot, and who can guess what's the name of the disease here? What do you think? So it's enlargement of the neck of the gland. Have you ever met it or seen it? Maybe in Russian you can say the name. Yes, the name is Zob, or in English goiter. It's Chumolite, enlargement scientist Gaspar Chatin. He understood that the lack of iodine in environment causes this goiter and causes problem with the brain and other functions of the organism. And actually he proposed a very simple method of treatment. You can tell the method of treatment of this goiter. If we have a lack of iodine in environment, the method is
taking more iodine.
Excuse me?
Taking more iodine.
Taking more iodine, especially to change a little the diet. So to eat more vegetable fruits with iodine. So he proposed this method, and it actually saved or made better thousands, even millions of lives. And here is the fruit. Who knows the name of the fruit? No.
Kava.
The fruit is here. The name of fruit is, I think you know the smell of it. You can smell it. Do you know it? What? Feihua, yes, exactly. It's Feihua in English, and actually it's a recordsman among all plants and all fruits on our planet. You have 1 milligram per 100 grams of iodine. So especially this fruit is used. Actually, Russia and Ukraine and a very large part of Europe has lack of iodine in environment. So during our talk, lecture, I will gift one Feijua for one right answer. So we will start from you, Daria. Let's discuss the science evolution. If we talk about evolution of science, we can see that in ancient times we had nature philosophers who studied all from literature, philosophy to physics and geology. Then we have in the 19th century the separation of science. We have physics, geology, biology, and so on. For example, here we have Roderick P. Murchison, who can tell us what he has discovered, a very prominent geologist. Exactly, yes. One of his discoveries was your name? Timur. By the way, to eat feihua, you need just to wash it, then cut it by a knife, and just eat it with a spoon. So he discovered the Permian system, and before that he actually discovered Silurian, and also was one of scientists who proposed Devonian system. He came to Russia by the invitation of our emperor and made very huge expedition from the Moscow to Urals, and he understood that Permian strata, which is here in southern and middle Urals, it is absent in, for example, England. And he proposed new system which is known from the name from the Perm city. And in 20th century we have a division of each science into different branches, like we have division of geology into geoecology, geochemistry, structural geology, and so on. And again, in 21st century we have a turn back to the beginning, to the ancient times, when we have a very important feature that interdisciplinary research. So now we have a lot of discoveries in the junction zone between different disciplines. So, but if in the example here we have just 3 centimeter movement of tectonic plates, and it created 5,000 kilometers in wide Atlantic Ocean. The same with the chemical elements, like here, I think you know this movie, it's, what is it? Yes, it's Shawshank Redemption, exactly. And your name? Ilya. Ilya, nice to meet you. So Shawshank Redemption, and I like very much praise there, Pressure and Time. One of the heroes read, the friend of the main hero, he said that Pressure and Time, it took 20 years for that lawyer to build this huge hole through his through his wall in his cell. The same is with elements. From every day, the lack or excess of element, it influences us, and it could not harm us in 1 day or in 10 days, but it could bring harm in, for example, 40 years. So it is the second principle of medical geology that small action repeated in a long period, it could make difference. What? Uranium, yes, yeah, you're right. Second page one for you. So radon is the decay product of uranium. And is it harmful or is it useful for our organisms? It is harmful, yes. When we inhalate it, and it also decay inside, and it has a radioactive influence on our organism. That's why, for example, we have different research in different parts of on our planet. For example, here is the map of France, and on the left image we have a map of radon activity in France, and the right image is children cancer incidence. And we have correlation between the increase of radon activity and the increase of children cancer incidence. Here on this chart, what we can say? What does this chart mean? For example, we have the Finland, Sweden, Switzerland, and Norway in the circle.
They are close to each other, and also there are some reasons that lead to the problem.
Yes, and what do you think? What reasons? Why Finland, Sweden? Actually, they are located very close, and actually, it's a geological reason.
Minerals.
Mineral, yes. What mineral? What rock?
Great.
Yes, exactly. You're right. Again, Nastya. We have a granite there, and granite has uranium inside, and uranium decays, and we have a huge amount of radon activity, and that's why we have a bigger amount of incidents, cancer incidents in these countries, comparing, for example, to Canada or UK. The same image is in USA. We have here on the left radon activity, on the right is leukemia or blood cancer. In addition, Paracelsus, he said everything is poison and everything is medicine. Both depend on the dose. And here the chart which shows is we have a lethal effect and poisonous effect of intake of any element. So if we have a lack of element, for example, calcium, if we haven't calcium at all, it has even be a lethal effect for us. Then it has an optimal effect, rather wide diapason. Then we have poisonous and lethal range. It is not only the reason of non-toxicity of element. Why do we have a wide range of element, of any element? What's the reason? The answer, the clue is the reason is inside in us. Who can say? Any element. So we have lethal and poisonous intake when we have a lack of element. Then optimal is rather wide range, and then poisonous and lethal effect when we have excess of element. Why optimal effect is rather wide? It depends on us. We are the reason. What's?
Maybe not in English, maybe?
Okay, in Russian.
Толерантность, толерантный диапазон, когда мы можем подстраиваться, получается.
Подстраиваться, yes, exactly. Adaptation in English. Yes, you're right. It's for you. So the reason is adaptation, especially when we are born in the region. For example, we are born in a region with granite, and we live there whole our life. We have adaptation, and that's why it is not so harmful for us. Comparing, for example, with the people who lived, for example, on limestones, they moved to the territory on granites. They have very huge risk to get cancer. For example, in our republic, Bashkortostan and Urals, we have a region there, a small village, which is situated on granites. And there is a situation that people who move from different regions to this village, mostly the risk of cancer incidence much higher among this group of people because they have not adaptation. They lived in different conditions. And that's why they need very much to use water filtration because intake of underground water with the uranium inside, it could cause problems. And where does elements come from? For example, if we have a lot of uranium in soil, what does it tell us? So we have a lot of uranium in soil, and then in plants, and then we eat it. And where does it come from?
From the deposits or
From
deposits?
from deposits. What deposits?
Like sedimentary deposit of uranium or
Yes, from the underlying rock. Yes.
Yeah.
And because source rock is the source of the uranium in the soil. Yes, your name?
Gustavo.
Gustavo. Nice to meet you, Gustavo. And one of the highest amount of uranium, especially again in the granite. And so soils, they inherit chemical composition of the source rock. Comparing, for example, granite, we have 4 grams per ton of uranium and gypsum only 0.7. So the soils on gypsum differs very much in uranium composition comparing to soils on granite. And here we can see the result. The houses using the clay of this area, the clay is radioactive, so they have radioactive house, and they do not know about radon, and they, for example, in winter time, they do not ventilate their houses because it's warm inside, and you don't want to ventilate at all. And they have radon inside their house, and that's why they have 12 times higher nasopharyngeal cancer incidence comparing to the average rate in the world. So 12 times higher, just because of these environmental factors. So if we consider rock cycle, we have first magma, and then we have weathering, then sedimentation, lithification, then metamorphic rock, and again magma. So the first, weathering, physical, chemical, or biochemical. Actually, it could be compared with the decay of pineapple using different organisms or chemicals in environment, but of course the time is much bigger. And after weathering, we have deposits. Who can tell what is the name of these deposits on the upper image? Maybe in Russian. Here. Deposits of physical weathering. What is the name of such type deposit? When we have just blocks of sharp angled rocks. The first letter is K. K in Russian. Who remember the first year of general geology? In Russian is Kurumnik. Remember? Yes. And after this Kurumnik, we have weathering crust, loose rocks, and then we have soil. It's actually weathering crust enriched with some organisms. And after that, we have transportation. So we have 4 main transportation forces in exogenic forces. Who can tell us? 4 forces. 4 different forces. It's very simple. You know them definitely. What?
Gravity.
What?
Gravity.
Gravity. Yes. First is gravity. Okay. Second.
Water.
Water. Yes.
Wind.
Wind and
Biological.
your name?
Yulia.
Julia, nice to meet you. 2 for you. For water and wind. So we have water here. We have wind. We have gravity and no exogenic. It's in mountains.
Glaciers.
Glaciers, exactly. You're right. So we have water, we have ice movement, then we have wind, and the last is gravitation, like landslides. And in the end, all these products using wind, using our digestion system, or just inhalation, or just even touch with rock, so contact with rock when we just walk It goes inside our organisms. And we have second, bush sickness. It's known in Australia, known in New Zealand. Here we have loss of energy, weight, and it's eventually leading to death in cattle. So here we have deficiency, lack of element, the left image, and the right image is after the correction of diet of the animal. They just put one mineral inside the food of animal, and it was a cure. So what is the element from the listed ones? Who can guess? You can just guess, try one. It is there. This element is the part of B12 vitamin first, and this element is very essential for blood construction and for our nervous system.
Copper? Iron?
No, not
Copper?
iron. What?
Copper?
What?
Kupfer or copper?
Cobalt.
No. Copper?
Copper. No, not copper. Zinc? No, no zinc. Zinc is also a very essential one, but no zinc. What is the part of B12 vitamin? Very, very important vitamin also in our organism. What? Magnesium? No. You said? No. Cobalt. Yes, it's cobalt. Cobalt is essential for B12. It's component and it's component also inside blood and nervous system, and it's part of metabolism system of our cells. So maybe you will be shocked, but actually geology influences not only our body health, it also influences our mental health. For example, here we have an element, and if we have a lack of concentration of this element in the drinking water, in the underground waters, we have problems with suicide mortality rates. So this element is part of the medicine of curing depression. What is the element?
Lithium.
Lithium, yes, exactly. You are Thomas. It is lithium. So lithium is very important for our mental health. And if, of course, there are many factors. Not only lithium causes suicide. There are also factors, social factors and genetics and so on. But the next one, skeletal and dental, and I will not tell you first this name of the disease because it's very similar to the name of the element. So we have, again, deformation of bones and also problem with teeth. And if you know the composition of the tooth of teeth, you will say the right answer of this element. Calcium? No. What? Phosphor, no? Phosphor, yes, exactly. Fluoropotash is the mineral of our teeth. Your name? Sasha, nice to meet you, Sasha. And the fluorine, phosphor, if it is actually excess or deficiency, both they cause the fluorosis, the name of this disease. It's very common, unfortunately, also in Russia and Lithuania and in China. Actually, geology could influence our health not only in 40 years, it could influence our health instantaneous. For example, here in Africa, in Cameroon, we have a lake which killed 1,746 people in one day, actually during 1 hour. And you should guess what was the process. What caused such disaster? What was the reason? Who can guess? Excuse me? No, it's with connected with the gas. Yes. What gas and why? Methane? No. Serowodorod? No. Ammiac? No. Okay, I will give you a clue. This lake is in the ancient crater or volcanic crater. So it has a gas inside because from the fractures, this gas goes up and it penetrates into the water. Sulfur gas? No. What gas gas also we have in volcanoes. You what? Yes, carbon dioxide, exactly. You're right, Sasha. So we have carbon dioxide, and this disaster, it could happen only in Africa, not in Russia. It's good for us. In Russia, this disaster is impossible. For the main reason is, actually, in Russia we have volcanoes, we have even lakes inside the volcanic ancient craters. They also have a penetration of the carbon dioxide, but in Russia we have winter. And what happens with the water in the lake during winter?
Frozen.
It's frozen, and that's why so in summer we have a very warm upper layer of water. In winter it became to froze, it cools, and this upper layer goes down. And we have circulation in water in Russia and in all regions, northern or southern, close to the southern pole. But in Africa, actually summer is the whole year. And that's why in Africa, in this lake, they had the hot, warm layer of the lake and the cold layer on the bottom. So it didn't mix. And this cold layer, it had penetration from fractures of carbon dioxide, and it has a huge amount of dissolved carbon dioxide inside. And then, what happened then? Why this carbon dioxide went up? So it went up and it killed everyone, this amount of people, and also 3,500 cattle, so cows, sheep, and even birds, in the radius of 25 kilometers. What happened there in 1986? Who can guess? Why did the carbon dioxide went up?
Volcano activity.
No, it was very calm.
Maybe it's because CO2 is heavier than oxygen and
Yeah.
all people live in
Yes, exactly. CO2 is heavier than oxygen. It went up and then it just went down to the valley. But why it was inside the bottom layer of water? Why did it went up? We talked about this energy, about this transportation energy with you on previous slides. Who can guess? What made the water to mix? No, not temperature. It was very momentous action. Imagine a huge spoon which mixed. What a natural process would be like a huge spoon mixed. What?
Wind.
No, not wind. Heavier. And the earthquake caused what? Pressure. And what happened with the rock during earthquake? Cracks and the rock falls down. Yes, you're right. So we had a landslide. Some geologists proposed that there was a small earthquake. Somebody says that no, because we haven't documentation, but mostly the main theory is we had a landslide there. So the huge amount of rock just went down inside the lake. It made it to mix, and CO2 went up. And then CO2, carbon dioxide, it couldn't dissolve again back to the water just in 1 hour. So it went just to the whole valley. And now, who can tell us what is the method to not to happen this again? The ecologists do now there in this lake and in the similar two lakes in Africa. What should we do? We hadn't such a huge spoon to mix the lake, but they use.
Make some special tubes.
Yes, exactly. Yeah, you're right. They use the tube here. CO2, and here is the tube. And CO2 just goes up from the bottom layer. I want to talk with you about one of the most important discoveries in geology. You know this man, Alfred Wegener. He proposed the theory of continental drift in 1912. By the way, how old was he at the time when he proposed it? What do you think? Approximately. What? 32. Exactly. Nasty, you're right. He was 32. I'm also 32, and when I think that one of the biggest discoveries was made by a man in my age, and I haven't discovered yet nothing so important, it falls me into depression. So he made it, and he gave three main factors, explanations of this theory. The first one, you know, what is it? First one is just the shore of Africa and Southern America, and if we just put them together, it corresponds. The second one is the zones of the ancient fauna and flora. For example, Cephalofagus, it lived in South America and Africa, and if we put together these continents, the zone is very logical. So it's very similar, yes. Also, he said that we have tillites. Tillites is, what is a tillite? What? Yes, exactly. We have a moraine and tillite. Nasty, again, you're right. Nasty is a champion today. We have a moraine, and tillite is ancient moraine, which is a lithificated moraine. So he said we have tillites in Africa and in South America, and it could happen only if Africa and America sometime was close to the southern or northern pole, and the climate was different. And also he said we have coal deposits, especially in Russia. And Russia is a cold country. And coal deposits, they were made in, for example, Carboniferous system, in very warm climate, tropical climate. And it could happen only if Russia was closer to the equator. Of course, geologists mostly all geologists of the whole world did not agree with him. By the way, how did geologists explain this Cephalofagus living here and here in very similar areas? How geologists of the whole world, because they had a fact and they need to explain it. How will they explain it? No, this Cephalofagus, it could not swim. It's very, actually comical explanation of the brightest minds of the world. It depends on that they did not know the structure of the bottom of the ocean. They thought that it was like just a lake. They proposed just bridges here. They just painted bridge that they said that sometimes in some periods the land goes up and we have a bridge and the animals just run here or there, bridge from Africa to Australia, from Africa to South America and so on. That's how they explained these areas. And three things was made that by non-geologists actually. It was made by meteorologist Alfred Wegener. So meteorologist was cleverer than the geologists of the whole world. It's the first funny thing. The second one is that it has been made not in expedition but in library actually. So mostly geologists made discoveries in expedition, but this was made by Wegener reading literature, in geological literature of Africa, South America, and just works of other geologists. And the third one, that it was ahead for 50 years of the knowledge of geologists of the whole world, because only in 1960s geologists understood that Wegener was right. When they studied the bottom of the sea using geophysics, and they understood that ocean crust is formed inside of middle ridges, oceanic ridges. So as conclusion, I want to say two things. That first, discoveries actually, they are around us. We just need to look attentively, and our discovery, it could save lives, thousands of lives if we understand these mechanisms of geology and medicine and ecology. And the second, that we should not be afraid of critique, because even the whole world could be wrong and you could be right. So, thank you very much. Maybe any questions, and let's keep in touch. Here is my social networks. We can, if you have some questions, or maybe if you conduct some research in medical geology, I will be glad to be in your team.